Good day everyone. Ngayon ay nasa chapter 7 na tayo. Application and processing of ceramics. Bago ang lahat, magpapakilala muna ako. Ako nga pala si Jeric M. Gonsalvo. Sa chapter na to kasama ko sina Allen Bautista at Santos Dexter. Application and processing of ceramics. Types and application of ceramics. So this report focuses on the different classification and definition of ceramics and how are they used in many ways. What is ceramics? The word ceramics is derived from the Greek word keramos, which means potter's clay. However, many compounds which are classified as ceramics today contain no clay. Potter's clay ay isang uri ng lupa na ginagamit sa paggawa ng mga kagamitan na kadalasan makikita natin sa ating mga tahanan, sa ating mga bakuran, sa hardin. Ang mga best example na to ay mga palayok, paso, banga, sa mga kitchenware katulad ng stoneware, ano pa ba, may mga toilet, bathtub, isang example na rin yung mga clay, mga potter's clay. Sa paglipas ng panahon, marami na tayong nadidiskubre. Katulad na lang dito sa ceramics, meron na tayong tatawag na modern ceramics. Modern ceramics ay meron siyang compound ng metals and non-metals. They are generally have ionic atomic bonding between them. At isa naman is traditional ceramics including insulating materials, glass, refractories, abrasive, and enamels. So, meron tayong two types of ceramics, crystalline ceramics and non-crystalline ceramics. So, crystalline ceramics. Crystalline ceramics materials are not amenable to a great range of processing. They are rigid, stable, and requires high force to deform. Ceramics are the types of ceramics. Crystalline ceramics are the types of ceramics that are strong and are not easily be broken by other factors. Ang mga ito ay matitibay at hindi mo siya basta-basta masisira. Unless kung lalagyan mo na lang siya or mag-a-apply ka na lang ng matataas na force o malalakas na force para basagin ang mga ito or ma-deform. Ang example ng crystalline ceramics ay potter's clay, dishes, glass, tiles, bricks, cement, mga ganun. Ganun yung ayun ang mga tinatawag na crystalline ceramics. So, ang other types naman ng ceramics ay non-crystalline ceramics. Non-crystalline ceramics are basically glass and are usually formed through melting. Shaping glass can involve either bringing the ceramics materials to a fully molten state and casting it, or bringing it to a semi-molten state like a caramel and blowing it into a mold. Non-crystalline ceramics can easily be bended through melting or heating. These are not suitable for strong amount of pressure for it's very fragile. Okay, glass is a non-crystalline, a faint transparent amorphous solid that has widespread practical, technological, and decorative uses. So dito makikita nyo kagad ang application ng glass ceramics na ginagamit natin halos araw-araw. Ang example nito ay glass window, drinking glass, reading glass, screen protector ng cellphone natin, sa kitchen. May mga ginagamit doon tayo na glass ceramics, hindi lang natin napapansin. Sa pole transformer, may parts doon na gumagamit din ng glass ceramics, and sa paggawa naman ng pustiso, ginagamit din ito or ingredients ganun sa paggawa ng pustiso. Glass ceramics combine the properties of glasses with the benefits of conventional sintered ceramics. Most commonly, they are manufactured in a process in which a pre-manufactured glasses is subjected to a specific heat treatment. This treatment results in a controlled nucleation and crystallization of the glass. The glass partially crystallizes, and the glass ceramics develop a structure comprising an amorphous glassy phase and at least one embedded crystalline phase. To sum it up, the glass ceramics are suitable for all types of economic uses because it is deformable to its desired uses. Ito naman mga properties naman ng glass ceramics materials. Ang una ay high strength, next is a high impact resistance, low coefficient of thermal expansion, sometimes even negative coefficient of thermal expansion. The fourth is good resistance to thermal shock, and lastly a range of optical properties from translucent to opaque and sometimes opalescence. Clay products. It is an artificial materials of construction in forms of clay blocks of uniform size and shape. Clay is mixed with a desirable quantity of waters and other ingredients, molded in required form, dry, and then burnt in a kiln. Ang clay product naman ay isang uri ng lupa. Tulad nga ng sinabi dito kanina na ang clay ay nilalagyan ng konting tubig tapos hinuhulma, pinapatigas. Mga common na makikita to sa mga house, sa mga construction, sa mga kitchenware, at ginagamit rin ito pa sa mga walls and mga toilet ganun. So ito pa yung ibang examples ng clay products. Ang una yung bricks. Ang bricks ay isang uri ng hollow blocks. Karaniwan ng bricks ay ginagamit sa paggawa ng mga bahay, mga structures, ganun. Sa Pilipinas wala masyadong gumagamit ng bricks. Siguro medyo may kamahalan. Ang bricks ay karaniwang ginagamit sa mga bansang China, Spain, India, France, Italy, at marami pang iba. Next naman is yung roofing tiles. Yung roofing tiles naman ay isang uri ng bubong o ginagamit na pang bubong. Karaniwang gumagamit na bansa nito sa mga naunang panahon pa ay yung bansang Korea at China. Makikita to sa mga temple nila. Next naman yung sanitary wares, like yung bathtub, na makikita natin sa comfort room. Mga gawang clay products rin yun. Then lastly yung mga stonewares like mugs and teacups. Next naman is refractories. Refractories are ceramic materials designed to withstand the very high temperature in excess of 1000 Fahrenheit 538 Celsius encountered in modern manufacturing. More heat resistant than metals, they are used to line the hot surface found inside many industrial processes. Ang refractors naman ay isang uri siya ng clay products. Ginagamit ito sa manufacturing industry. Para siyang mga maliliit na mga bricks din na ginagawa siyang parang isang malaking drum. Yung drum na yun, dun pinaprocess yung pagme-melt or hindi kaya pagpapainit ng mga bakal na hinuhulma naman base naman sa design ng project or sa design ng product, ganun. Next naman is abrasive ceramics. Abrasive ceramics are used to grind or cut away other softer materials. Primarily, when considering the design of abrasive materials, it is hardness and wear resistance that are of the most important. Toughness is also considered as a necessary requirement so that the abrasive materials does not shatter during grinding. May iba't ibang uri ng abrasive sa buong mundo. Dito sa Pilipinas, commonly, ang abrasive na kilala natin ay yung sandpaper or liha. Yung iba naman ay cutting disc, grinding wheel. Ginagamit ito sa pagpapakinis or pagpuputol ng mga metal. Ang abrasive ay para lang siyang buhangin kung makikita nyo, tapos hinahaluan lang siya ng ibang materials para tumigas at maging matibay kapag ito ginagamit na. So next naman, cement ceramics. A cement is a binder, a substance used for constructions that sets, hardens, and adheres to other materials to bind them together. Cement is seldom used on its own, but rather to bind sand and gravel together. Ang cement naman, kinonsider siya na ceramics kasi may para rin siyang potter's clay o clay product. Ang kaibahan lang nila, isa siyang powdered chemical na inahalo sa buhangin at graba at yun ay tumitigas, parang totally habang buhay na siyang matigas at hindi rin siya basta-basta nababasag, ganun. Commonly ginagamit ang cement sa paggawa ng bahay, building, karsada. Ginagawa rin siya ngayon, ginagamit din siya sa paggawa ng mga paso at mga flower vase, ganun.
Next is advanced ceramics. Advanced ceramics are differentiated from traditional ceramics such as brick and porcelain by the higher strength, higher operating temperatures, improved toughness, and tolerable properties, also known as engineered ceramics. These materials are replacing metals in applications where reduced density and higher melting points can increase efficiency and speed of operation. Kaya nga siyang tinawag na advanced ceramics kasi mas matibay, good din yung applications niya sa higher temperature o sa may init. Then may iba namang advanced ceramics na may resistance against vibration and mechanical shock. Pwede din natin gamitin itong advanced ceramics bilang substitute sa metals because of their strength and toughness na almost the same with metals. Dito, ginroup yung types ng advanced ceramics according sa kanilang applications. First is electroceramics. Are advanced ceramics materials that are used in wide variety of electrical, optical, and magnetic applications. The first use of ceramics in industry took advantage of their high electrical resistivity. Dahil nga sa high electrical resistivity and magnetic applications, kadalasan itong electroceramics ay nasa components ng mga electronics. Ito ay kadalasan ginagamit sa light emitting diodes, laser diodes, microwave amplifiers, high power switches, and solar cells. Next naman is dielectric ceramics. Dielectric ceramics are materials that are used for a range of high voltage capacitors because of their capability to support electrical fields and or to act as insulators. Dielectric meaning pure conductor ng electricity, pero good storage ito ng electrical energy. Kaya kadalasang nasa capacitor at iba pang electronic devices yung application nito. Next is fast ion conductor ceramics. Are solids in which ions are highly mobile. These materials are important in the area of solid state ionics and also known as solid electrolytes and superionic conductors. These materials are useful in batteries and various sensors. Fast ion conductor are useful mainly in solid oxide fuel cells. Ito namang fast ion conductor ceramics, kadalasan yung application nito is for sensors, batteries, fuel cells, at mga electrochemical devices. Katulad ng dielectric ceramics, good energy storage din to. Next is piezoelectric ceramics. The characteristic of converting mechanical energy to electrical energy and from electric energy to mechanical energy is called piezoelectric. In other words, piezoelectric materials will expand or contract when subjected to a volume and generate a voltage when subjected to a pressure. Ito yung piezoelectric, isa sa mga pinakamay malawak na application dahil sa kakayahan nitong mag-generate ng electricity. Ito kasing piezoelectric, punong-puno siya ng mga charges, positive and negative. Kaya kapag nag-apply tayo ng pressure, yung mga charges na nandito is nare-release, then nakakonvert siya sa electrical energy. So, ito yung itsura ng mga piezoelectric ceramics. Some of our piezoelectric ceramic application includes medical, bone conduction, hearing aids, ultrasonic surgical instrument. Sa communication naman is antennas and sensors. Nagagamit din siya sa optics, fiber positioning, and turntable lasers. Next is magnetic ceramics. Oxide material that exhibit a certain type of permanent magnetization called ferrigmatism. Commercially prepared magnetic ceramics are used in variety of permanent magnetic transformer, telecommunications, and information recording applications. Yun nga, magnetic ceramics, may property lang siya ng magnetism, kaya tinawag siya ng magnetic ceramics. Kadalasan itong mga magnetic ceramics natatagpuan natin ito sa mga laruan sa dynamo. Ganyan yung shape niya, and sa ceiling fan, maliliit na ceiling fan, nakakita na rin ako ng ganyang magnet. Next naman is optical ceramics. Transparent, glassy, or crystalline structured materials engineered from inorganic, non-metallic materials via various methods that include heat or specific chemical reactions. Optical ceramics have been found useful in area of thin films, coating fibers, and also known to be advantageous substitute to common optical materials such as glass that are traditionally used for applications such as laser windows and lightweight armor. Itong optical ceramics, parang glass lang siya, kaya nga sinabi na maaari itong gamitin bilang substitute naman sa glass, tulad ng laser windows and lightweight armor. Next is advanced structural ceramics. Itong advanced structural ceramics naman, ceramics materials that demonstrate enhanced mechanical property under demanding conditions. Because they serve as structural members, often being subjected to mechanical loading, they are given the name structural ceramics. Itong structural ceramics, based na rin sa name niya, ginagamit for structure purpose. Depende na lang sa kung saan application siya gagamitin, may iba-iba din siyang properties. Ito, may 4 na type tayo ng advanced structural ceramics versus yung nuclear ceramics. Itong nuclear ceramics, ginagamit ito bilang nuclear fuel to generate nuclear power. Ito namang bioceramics, ginagamit ito for medical treatment. Itong bioceramics, kapag may nasisirang buto o ngipin, ito yung bioceramics yung ginagawang substitute. Next naman is tribological ceramics. Ito namang tribological ceramics, lang siya, resistant to friction and wear. Itong tribological ceramics, ito yung ginagamit natin sa tip of ballpoint yung kadalasang nasa dulo ng mga ballpen natin. At ginagamit din ito bilang bearing. Ito naman automotive ceramics. Base na rin sa name niya, automotive ceramics. Nagamit siya sa mga automobiles tulad ng kotse. Dahil sa strength niya, pati may resistance siya sa corrosion. Meron pa tayong types ng advanced ceramics na based naman sa kanilang compositions. Itong nitride ceramics, may composition ito ng nitrogen and bonded to such as silicon and aluminum. Ito ay high performance technical ceramics that is extremely hard and has thermal shock and impact resistance. Ito namang silicate ceramics, composed naman ito ng silicon and oxygen. Ito naman ay ginagamit to provide thermal insulation, meaning reduction of heat, para makontrol yung heat natin. Kadalasan ng application nito na sa mga fuses, circuit breaker, thermostats, and lighting technology. Next is carbide ceramics. Ito namang carbide ceramics, composed naman ito ng carbon. May resistance naman ito against high temperature, abrasion, and corrosion. Next is oxide ceramics. Oxide ceramics naman composed of oxygen and combined with at least one other element. Ito mismo yung oxide ceramics yung ginagawang tools, wear protection, and meron siyang high melting points and lower wear resistant. Next, fabrication and processing of ceramics. Ceramic processing. The higher performance of ceramics is the result of strict control of purity, composition, microstructure, and processing. So, nagiging depende yung performance ng ceramics sa kanyang processing. Kaya, dapat kinokontrol yung kanyang composition, microstructure, and yung processing niya dapat limited lang. Because of that inherent brittleness, ceramics cannot be formed by rolling, extrusion, drawing, etc. Pag sinabi nating brittleness, sila yung matitigas na bagay pero nababasag sila. Tulad na lang ng porcelain. So, dahil doon, limited lang yung process na pwedeng gawin para ma-form sila. Their high melting temperature also a restriction on the use of casting tapes. Yun, high melting temperature din to ng ceramics, kaya hindi rin pwede gamitin yung mga casting techniques. Usually, sa paggawa ng ceramics, may 4 na steps lang, yung powder processing, forming, sintering, and finishing. Powder processing. The characteristic and condition of the starting raw materials in which they are treated prior to sintering affect the final outcome of this technique. Dito sa technique na to, kailangan strict din yung paggawa natin kasi nga maapektuhan din ito kung yung final outcome na magiging product. So dito, yung characteristic ng powder ay dapat kasama yung size, shape, size distribution, degree of segregation, and agglomeration. Finer and homogeneous particle are preferred. So, dapat finer and homogeneous. Pag sinabi natin homogeneous, dapat same sila ng size, halos wala na silang pinagkaiba. Halos iisa na lang sila. Preparation of the starting powder include crushing and grinding to the desired size range and chemically treated to separate paste and compounds and to achieve specified purity. Dito sa powder processing, yun nga, kinakrush sila and ginagrind para makuha yung desired range nila. Dito naman sa forming, the powder is consolidated into a compact by shaping in a mold with the application of pressure, cold compaction or heat compaction. Water or plasticizers are added to allow the paste to form into the desired shape. Dito sa forming, ginagawa silang compact o mas solid. From powder, dito naman ginagawang solid gamit yung cold compaction o heat compaction. Dito nag-add sila ng water o plasticizers. Itong water o plasticizer, ito yung parang nagiging pandikit para dumikit yung powder sa isa't isa. Pag nag-add ng plasticizer, nadadagdagan din yung parang flexibility ng materials, tsaka nababawasan yung brittleness nila o yung pagiging babasagin. Usually may apat na methods dito sa forming. May pressing, slip casting, tape casting, and injection molding. Powder processing. Powder pressing is the compaction of powder into a geometric form. Dito sa powder pressing, base na rin sa na-imply ng name niya, powder pressing, yung powder, iniipon siya tapos naglalagay ng force para maging solid siya. Tapos yung kalalabasan naman nito is tinatawag na green compact. Yan, parang dinidikdik lang natin yung powder hanggang sa maging solid siya. Dito sa slip casting, a slip is suspension of clay and other non-plastic materials in water. Preparation of powder ceramic material in a liquid and a clay water into a stable suspension called slip. Dito, yung slip, ito yung mismo yung mixture na nabuo gamit yung plasticizers and yung powder na ceramics. Pouring the slip into porous mold usually made of plaster of Paris and allowing the liquid portion of the slip to partially absorb by the mold. And as the liquid is removed from the slip, a solid layer is formed against the mold surface. So, dito nga, yung slip na nabuo gamit yung powder ceramics, ibubuhos siya parang sa kanyang hulmahan. When the sufficient mold techniques has been formed, the casting process interrupted and the excess slip is poured up the cavity. So, yun. Dito, para may certain time na hinihintay tayo para yung mga nasa gilid ng huhulmahan is natuyo na, and yung nasa gitna, liquid pa yon. Syempre, tatanggalin natin yung liquid sa gitna. Tapos, hintayin na lang natin patuyuin yung wall na nabuo sa gilid ng hulmahan. The materials in the mold allows to provide adequate strength or handling and subsequent removal of the part of the mold. So, yun nga, pag natuyo na siya, tatanggalin natin yung hulmahan niya. Yung hulmahan, usually, lang yan, ina-assemble and pwede rin kalasin pagkatapos ng process. Pag natuyo na, pag tinanggal na natin yung hulmahan is lalabas na yung product natin. Usually, itong slip casting, ginagawa lang to sa mga clay product. Dito na naman sa tape casting, the sheets of flexible tape are produced by casting. These sheets are prepared from slips. The slip contains suspension of ceramics particles in organic liquid that also contains binder and plasticizer to enhance strength and flexibility to cast. Sa tape casting, yung nabuo nating slip is ibuboost natin sa machine ng pakonti-konti. Tapos itong machine naman is magpuproduce siya ng parang manipis na layer na parang tape galing doon sa binuhos nating slip. So yan, sa tape casting mas nagiging solid yung mas dikit-dikit yung yung powder. Tapos maaari pa siyang mas patibayin ng sintering. Dito naman sa injection molding of ceramics, the cost-effective and flexible process that provides solution for design engineer and requires complex repeatable ceramic components. Dito sa injection molding, una, iniinit muna yung slip. Tapos, pag mainit na yung slip is parang may machine na ibubuhos mo siya doon, and then yung machine naman i-inject siya sa hulmahan kung ano ba yung product na gustong hulmahin. Tapos hihintayin matuyo, tapos katulad rin siya ng slip casting, tatanggalin din yung hulmahan, tapos pag lumamig na, lalabas na yung final product. Dito naman sa sintering. Sintering or pretage, the process of compacting and forming a solid mass of material by heat pressure without melting it to the point of liquefaction. Dito sa sintering, parang mas lalong pinapatibay lang yung product na nabuo mula sa forming. Iniinit sila iniinit sila na hindi pa aabot sa kanilang melting point. Dito naman sa finishing, if fine ceramic is porous and fluid impermeable is desired, or if a purely decorative finish is desired, the product can be glazed. Dito sa finishing, ginagawa lang ito kapag yung final product is kailangan pang kulayan, i-glaze, o di kaya ikinisin o pakinisin. Yun lamang po. Salamat.